in this video, we are going to look at potential dividers, okay? We're going to look at what a potential divider circuit is. We're going to look at the potential divider equation, as pointless as that is, because really, this is the same as internal resistance. If you have a good understanding of the circuit rules, resistances, and Ohm's law, you're really not going to need to use this equation at all. I've never come across a point where I need to use this equation because I think it's just one more equation you need to learn. I'll show you it anyway, and I'll show you why it's pointless, but it's in the specs, so you do need to be aware of it. But like I said, most of you will be able to live without it and live without learning it, and really just stick with what you already learned. So you're learning less, but you're just learning learning what you've already done better as a result of it. So I'll show you what I mean. Right, well, a potential divider circuit is a circuit that divides potential. So in any circuit you've got a power supply, so we'll say we've got, we'll just put 12 volts in there, that's fine. We've got two resistors that make up a potential divider circuit. Okay, you have to have two resistors to have a potential divider circuit. You're not going to divide the potential if you don't have more than one resistor. If you've only got one resistor, then all you'd expect out, because of Kirchhoff's second law, is whatever you put in is whatever you get out. So if you just have one resistor, let's say, remember, then you'd only get out your 12 volts across there, 12 volts in, 12 volts out, that's what you'd expect. So in terms of a potential divider circuit, what we're talking about here is where we've got two resistors. Now, you might have already realised from doing experiments in class that if you've got identical resistors in a circuit, then you would expect there to be identical potential differences across the two resistors. So for example, in this case, if we had 100 ohms here and 100 ohms here, the potential would be divided. And what we would expect there to be an equal distribution of energy across these two voltmeters. So you have 6 volts across that one, 6 volts across that one. Now, a lot of people think, well, it's kind of weird that if I was to change the resistances of these, the situation wouldn't change at all. So if I still have two identical resistors, but they're, let's say, 1,000 ohms, a piece, then we'd still observe 6 volts there and we'd still observe 6 volts there because the resistances are identical. However, what happens when we change one of these resistances? We'll talk about that in a second. Why is this the same? Well, the only thing that changes in this circuit when I went from the 100 ohms or 200 ohms, whatever it was before, to 1,000, in both cases, is the fact that the current is the thing that's going to change there. The potential difference is not affected by the current, it's affected by the resistances that are there. So what we've got here is a situation that we can change up just slightly and say, well, what happens then if I was to introduce different resistances? Let's say I have 500 ohms and I have, let's say, 200 ohms. How do we know how that potential is split? Well, there is an equation to help you work it out. But we have to assign letters to make this work. So we're going to call this one V2, or V out in fact. This is called V in. We're going to call this R2, we're going to call that one R1. And the equation as it's stated in your equation sheet looks like this. That V out is equal to R2 over R1 plus R2 times by V in. that equation, for all intents and purposes, is so pointless. I'm going to show you why that's pointless. Because you have to make sure, this actually makes more sources of error than anything else. I genuinely don't know why we use this. So, V out is the V out always across R2 for this equation. So I've had to assign this the letter R2. If it hadn't already been assigned the letter R2, I might have made a mistake in assigning it R1 and then trying to do it that way around, and you make a mistake. You get it wrong. V in you won't make a mistake with, but where V out is always V out across R2. I'm not saying that you shouldn't use this equation. I'm saying this equation is for people who aren't confident with their circuit rules and feel like they need that kind of crutch. If you feel like you need that, great. But most people will see in a second that actually you don't need it. So how would I work this out? How would I work out what the voltage out is across here? Well, I would just use Ohm's law. And the same concepts that I've shown you in previous videos, where I look to see, what do I know three things about? Do I know three things about a resistor? If I don't, I need to use other rules to help me get to the point where I can work out the three things, or have at least two things, so I can work out the third using Ohm's law. So in this case, what I'm going to do is I'm going to say, okay, well, I know that this is 500 ohms and I need to work out the voltage out. What am I missing about this? Well, I'm missing, from Ohm's law, the current. V is what I want to find out. The resistance is 500 ohms. And the current is unknown at this point in time. But is there a way of working out the current in this circuit? Yes, there is. So what we've got here is a situation where we can go, oh, I know that I've got 12 volts in. I've got two resistors in this circuit. I can work out what the current in this entire circuit is. How do I do that? Well, if I look at this here, I've got 500 plus 200. Look at that, they're in series. I know what the total resistance of this circuit is. So I know that the total resistance is 700 because of the resistances in series. I know that the total voltage, or the total EMF, is 12 volts. What can I work out? Well, I can work out the current that is going to be running through this circuit. So how do I work that out? Well, Ohm's law is V equals I times R, so V over R will equal the current, which in this case is 12 over 700. And that's going to give me a current of, when I work it out, so 12 divided by 700 is 0.0171. So 0.0171 ohms. So if that's the current there, is the current going to be any different there? And is the current going to be any different there? Hopefully you should be telling yourself, actually, no, it's not any different. There's no difference whatsoever. And so as a result, I can then tap in that current there, 0.0171. I now need to know what the voltage is out across R2. The resistance is the 500 ohms. So V is equal to I times R, which in this case is going to be our 0.0171 times by 500 gives us 8.57 volts. So my understanding of Ohm's law has allowed me to work this out. I haven't learned anything new. I just basically looked at this circuit and said, oh, I can apply the resistance in series rule. I can then work out the current in this circuit using Ohm's law. I can then work out the voltage in my one resistor by using Ohm's law again. Or you could use the equation over here. So if we look and do this equation as we've shown here, so R2 is 500 ohms divided by 500 plus 200 times by the voltage in, which is 12. That will give us, I think you'll probably find, oh look, it's exactly the same answer, 8.57. Now you might be thinking, well that's quicker. And yeah, it is quicker, but the opportunity for mistakes is more. Now you might decide that which one of these ways is best for you. You will be looking at this way and going, oh, there's a lot more working that side, but it's using concepts you've already learned. It's just applying them to a new situation. And that's the kind of logic I would be expecting you, and most people would be expecting you to realise. Please note that all you're doing in this calculation is all of this in one calculation. So what you end up with is, if we look very carefully at this calculation, we can suggest that the V out that we have here is I times R, where I is I total through the circuit. Funnily enough, that value right there. And if we then look at it from the point of view as, oh, well, how would I work out I? Well, I would work it out by using this calculation up here. And if you notice very carefully that V in, we can change this calculation to be V out is equal to V in R2 over R1 plus R2. Well, look what we've done here. V in over R1 plus R2. That's what I've done there. R2 times by that value. Oh look, that's what I've done there. So all I've done with this equation is I've explained where that is, where that's coming from, and I've shown the steps, but here it's all done in one. So you need to decide which way you prefer to do it and see if you can work out some in your own time as well. Have a look at your textbook, see what you come up with, and we'll have a go at some more of these in lesson. Next video we're going to look at the kind of components that allow you to get variable versions of this, and then also describing the action and the ratios.